As in the last examples, different samples may get different results. Knowing the purpose of the sampling is very important. If the sample size is too small, if it is not randomized, or if the method of obtaining samples is not well thought out, you will get biased results. Bias comes from how a question is asked, as well as who is being asked. Surveys or statistics that are biased do not return valid results. One kind of biased sample is a convenience sample, which is made up of people who are easily accessed. For example, if a survey question is about building a new indoor sports facility in a city, and only people using an old indoor sports facility are surveyed, the responses may not represent the opinion of the entire city. Another kind of biased sample is a voluntary sample, which is made up of people who want to respond to the survey. For example, if a survey question appears at the bottom of a receipt, the only people who respond are those who care enough to tear off the survey from the bottom of their receipt and mail it in. The responses from this sample may not represent the opinion of all the store's customers. It's important for questions or surveys to be unbiased. That way, the results mean something. It is very important to remember that a biased sample will always be biased. It doesn't matter how much data is collected, it will not fix it because the data will always be collected in a biased fashion. A biased sample does contain some information about a population, but you must be cautious of the interpretation. For sampling to be unbiased, it should be randomly chosen from a population. Random samples are just that, they're random. They are used frequently because they tend to represent the population chosen, since randomization does not systemize some participants over others. There are several different types of random samples that can be chosen from, depending on the experiment or study. The first one is a simple random sample, or SRS for short. In this case, each possible sample size, n, has an equal chance of being selected from the population, capital N. In a stratified random sample, the population is divided into non-overlapping parts called strata. That's where the strata from the beginning of stratified comes from. And a smaller simple random sample is selected from each part. So for example, a survey could be given to 5 random students in each homeroom. The fact that they're using a homeroom separates the population into smaller, non-overlapping parts, and then 5 random students are chosen from each one. Systematic random sample is when the surveyed population is selected according to an interval of time or to an item interval. So a survey could be given to every 10th student who enters the building. There's a system involved. There's a set number that they always abide by in order to select the next person. That's a way to remember what systematic is. Another one is called a cluster sample. This is if the population naturally consists of heterogeneous, non-overlapping groups or clusters. Then a simple random sample of clusters can be drawn, which creates this sample. So for example, selecting 5 seniors from each neighboring high school would be a cluster sample. A census is another type of sampling method. It is different from the others because it selects all the items or subjects within a population. If you think about our population census that happens every 10 years, we all receive a form that needs to be filled out. So it goes to everyone within the population. Once a sampling method has been well thought out and proven to not be biased, one must consider the sample size. As a rule, small sample sizes will result in a large variation, while larger sample sizes result in less variation. Let's try an example. You are a quality control manager at an ice cream factory. Out of the 4,000 gallons of ice cream they produce in one day, you choose 4 of those gallons to pull off of the lines to check for quality. Is this enough? And if so, explain why it is sufficient, and if not, determine a range of values that would be sufficient. Well, if we take a look at this, the problem is saying that 4 out of 4,000 gallons of ice cream are being checked, or 1 out of 1,000 when it reduces. And that's also equivalent to being 0.1%. Or 1,000th. Is this considered to be enough? The answer here is no, it's not considered to be enough because it's such a very small portion of the sample that is being inspected. So sample size is too small. And also, if not, determine a range of values that would be sufficient. Well, this could vary. We could make it, instead of being 4 out of every 4,000, we could make it be 4 out of every 400, or 1 out of every 100. That would be 1%. And if you wanted it to be more accurate, you could say 2 out of every 100. Or 2% that come off the line get inspected. And here is also a solution worked out for this problem. It does agree with what we said. No, the 4 out of every 4,000 or 1 out of every 1,000 is not enough, not sufficient. And the answers can vary based on the interpretation of sufficient. We could end up having, for every 100 gallons, 2 of them are checked for quality. That's a sample answer.